The length in centimeter of the leaves of a particular type are modeled by normal distribution. Mean is given 5.2 and standard deviation is given 1.5. Find the probability that find the probability that a randomly chosen leaf of this type has a length less than 6 centimeter. So we have to find probability. We have to find probability of x less than 6. Okay, so this is going to be same as probability of z less than 6 minus 5.2 divided by 1.5. Okay, fairly simple question. So this is probability of z less than 6 minus 5.2 divided by 1.5. It's 0.533. 0.533. Okay, so this is equals to now 0.533. 0.53 is here and 3 is here. So 0.7029. 0.7029. It's 0.7029. Correct? We can round it and we can write this as 0.703 as well. Okay. Now second part of the problem, 5b. The length, what happened? Yeah. Okay, 5b. This is the problem. The length of the leaves of another type are also modeled by normal distribution. A scientist measure the length of random sample of 500 leaves of this type and find that 46 are less than 3 centimeter long and 95 are more than 8 centimeter long. Find the estimate for mean and standard deviation of the length of the leaves of this type. So now n is given 500. We have to estimate for mean and standard deviation. Okay, so what we do here, it's little tough. Here the problem is so I will say that probability of x less than 3 is equals to 46 divided by 500 and possibility of x greater than 8 is 95 divided by 500. Okay. Now possibility of x less than 3 means possibility of z less than 3 minus mu divided by sigma. A is equals to 46 divided by 500 gives me 0.092. And here possibility of z greater than 8 minus mu divided by sigma is 0.19. I hope you understand, right? So now this is the probability. Okay, if I draw the graph will be something like this, and in this graph the possibility of 0.092. नहीं नहीं मैडम कोई requirement नहीं. So possibility of z is given. Okay, so 0.092 means this part will cover, and 0.19 again you have this part cover. Okay, this possibility is given 0.19, this possibility is given 0.092. Okay, so let us first concentrate here. Okay, as this part is 0.19, the other part will be 1 minus 0.19. So 1 minus 0.19, if I see it is 0.81. So what we'll do here, we will see where is 0.81. So 0.81, if you see, this is 0.8106, or here 0.81 means 100 minus 78. So 22, so 22, where we are getting 22? Here. Oh, last time also we got the same thing. So it's a 0.8, 0.878. So 0.878. So here 8 minus mu divided by sigma, I will say that this is 0.878. And similarly 3 minus mu divided by sigma. So see here, this whole part, if I transfer on that part, it is one and the same thing, only the sign. Okay, sign here in this case is negative, so minus sign, and I will say that 1 minus, here also 1 minus 0.092. So this comes out to be 0.908. Now 0.908 I will see 0.908, 0.908. So here 900, so 908. So 908 means suppose 9080 minus 8997. What happened? I made some mistake, I think. 1 minus 0.092 is a 0.908. Yeah, 0.908. So 0.908, 0.908. I will rub first all these things. Now 0.908. So 908, 0.909, 0.908. So 0.908 is somewhere here. Okay. So 1.33. We can consider 1.33 or 1.329 as well we can consider. So if I say this, then 9080 minus 9066 is 14. So 14 is here. So 1.3 to 1.329 minus 1.329. Now here these are the two equations, linear equations that we can solve. So therefore I have two equations. One equation is 0.878 times sigma plus mu is equals to 8. This is one equation, and the other equation is minus 1.329 sigma plus mu is equals to 3. Okay, so we use calculator to solve this. 0.878 1 8, then minus 1.329 1 and 3. So the result for sigma, we will get sigma as 2.26 2655 to 2.266 we can say, and mu is 6.011 6.011. Okay, now C part. In a random sample of 2000 leaves of this second type. Okay, so for second type we have got mu and sigma. So in a random sample of 2000 leaves of the second type, how many would the scientist expect to find with a length more than one standard deviation from the mean? So probability of z greater than 1, I will say. So probability of z greater than 1, now again in the chart, for 1 it is 0.8413. Z greater than 1 means 1 minus, it's 1 minus, I will say that it is equals to 1 minus phi of 1. So 1 minus phi of 1 is 1 minus 0.8413. 0.8413. Now 1 minus 0.8413 will get, this is 0.1587. So probability of z greater than 1 is 0.1587. I have to find out of 2000 leaves how many would we expect have a standard deviation more than 1. So now possibility we got, we simply multiply this value. Acha, wait. I think we have made one error. If a random sample of 2000 leaves of this type, how many would the scientists expect to find the length more than one standard deviation from the mean? So for z greater than 1 or for z less than 1. So the same is going to be possibility of z less than minus 1. So this is also one standard deviation more. This is also 0.1587, right? So therefore, required number, how many would? So therefore required number of leaves will be equal to 2000 times 2 times 0.1587. So this multiplied by 2 times 2000. So 634.8. 634.8. So we can round off and say 635. So we round off this and say 635. Okay.